Hello, Jai Jagannath. This is question on a sequence. So let's discuss about the question. Here is given that give an example of a sequence of rational numbers that converges to an irrational number. Here is given a sequence that must be an rational number. मतलब ये है कि उस सीक्वेंस के सारे टर्म्स क्या होंगे, रेशनल नंबर्स होंगे, एंड दैट limit of convergence will be irrational number. That means the sequence where it will let that sequence may be an and all the terms belongs to rational number and limit n tends to infinity an L, that means L belongs to Q complement. So here will be n can be 1 plus 1 by n to the power n, which converges to E. Here all the terms of an are rational numbers, but the limit of convergence is irrational number. Friends, you got an example. Okay, if you want it's how this sequence converges to E, then I will prove this at the end of the video. Okay, so let's discuss another problem. Okay, here is another question. Give an example of a sequence of irrational numbers that converges to a rational number. That means there is a sequence whose all terms are irrational numbers, but the limit of convergence will be rational number. So that can be, I think, let that example be an is a sequence where an is 2an minus 1, where a1 is given root 2, then its all terms will be a1 is given root 2, then a2 is root 2 into n. If we put n equal to 2, then it will be a1, then it will be of root 2 over root 2. Then a3, if we will divide, then it will be like this. A4 will be like this, and the limit of convergence is here an converges to 2. All the all the terms are irrational numbers, but the limit of convergence is a rational number. If you want how this sequence converges to this, then you will get the proof at the end of the video. Okay, so now let's prove that two sequences that we have written before. Okay, the first first sequence was an is 1 plus 1 by n to the power n. Here you can clearly see that all the terms will be rational. Why? Because here n is natural number, here n is natural number, 1 by n is a rational number, then 1 plus 1 by n is a rational number. Rational number to the power a natural number is a rational number. So let's prove that sequence how it converges. Let's check that. So here what we will do, take log on both sides. Okay, on both sides. So log n will be 1 plus 1 by n to the power n. इधर लग लगेगा. ओके, तो ये क्या हो जाएगा, n लग 1 प्लस 1 बाई n. ये लग का प्रॉपर्टी होता है. मैं साइड में लिख देती हूँ. इफ log a to the power n equal to, suppose b to the power n equal to n log b. So now take limit on both sides. Take limit on both sides. Okay, if we'll take, what will happen? Limit n tends to infinity log an equal to limit n tends to infinity a log 1 plus 1 by n. If we will put n, here will be infinity, here will be 10 log 1 equal to 0 हो जाएगा. तो इसमें हम क्या करेंगे? अभी लिमिट n टेंड्स टू इन्फिनिटी log 1 plus 1 by n by 1 by n, that will be 0 by 0 form. Then we will apply L hospital rule. That is equal to limit n tends to infinity. Then हम ऊपर की डेरिवेटिव करेंगे, नीचे की डेरिवेटिव करेंगे. तो ऊपर की डेरिवेटिव क्या हो जाएगा? log 1 plus 1 by h हो जाएगा 1 by 1 by 1 plus 1 by n, and 1 by n का जब आप करेंगे हो जाएगा minus 1 by n square divided by minus 1 by n square. इधर 1 by n square 1 by कैंसिल हो जाएगा, हो जाएगा 1. ओके, then what we get? Limit n tends to infinity log a n equal to 1. पर हमें यहाँ क्या जानना है? हमको ए एन की लिमिट बताना है. सो यहाँ पर log एक कंटिन्यूस फंक्शन होता है, तो क्या होगा? लिमिट उसके अंदर जा सकता है, तो गया. उसके बाद log जब उसकी इधर आएगा तो क्या हो जाएगा? e to the power 1 इक्वल टू e हो जाएगा. तो हम यहाँ दिखा सकते हैं क्या हो गया. n goes to a. Okay, then do next proof. Next proof में n was like to n minus 1 where a1 equal to clearly you can see here a1 equal to root 2 a2 equal to a3 equal to 2. Clearly we can see an is a mono increasing sequence. Then if we proved that this sequence is bounded, then we are almost done. Okay, so here an equal to this. If we will square both sides, that it will be like that, like this. Then we know an greater than an minus 1. That implies n square greater than an minus 1 the square. So can we write 2an minus 1 greater than an minus 1 row square? Because this equal to this and this is greater than this, that implies this is greater than this. Okay, so let's do that. 2n minus 1 minus an minus 1 row square greater than 0. If we will take common an minus 1, will be 2 minus an minus 1 greater than 0. Okay, if both are 0, if this into this greater than 0, and we already know the new an minus 1 greater than 0, that is 2an minus 1 greater than 0 also that implies that is also 0, that implies 2 less than greater than n minus 1, that implies 2 greater than n minus 1 greater than 0. For all n this will satisfy because we have taken that n is arbitrary, so this will satisfy for all n. That implies an is bounded. Here n is monotonically increasing and bounded. So by monotone convergence theorem, n is convergent. So let limit n tends to infinity n equal to L. Okay, we are given what? An equal to this. If we will take limit both sides, then that will be L equal to 12. That implies L square equal to 12. That will be L square minus 2 equal to 0. That implies L into L minus 2 equal to 0. That implies L equal to 0 or L equal to 2. Okay. See, L equal to 0 it can't be, because we know that L is an increasing sequence, so it can't goes to limit 0, and so it will be L equal to 2. So limit n tends to infinity n equal to 2. It is a sequence of irrational number. It is a sequence of what? Irrational number. See, it is sequence of irrational number. But what we get? We get that it converges to a rational number. Okay. So here we get. So can you guys give me an example? Give an example of a sequence which is non-zero but converges to 0. Okay guys, thank you, bye bye.